Next step is what we want to do is we want to average the other averages, which is the grand average. Suppose we have 10 average files. We want to average them and find what is the average of the averages, which is called the grand average. So let me just go to file. No, sorry, not file. First, we need to load. So then what we will do is we will use combine conditions and then we will load the files. Let us go to the file list, load file list. We have already S1 to S10, 10 different subjects. You can add more if you have. So you can make a file list similarly. So here I have a merged auditory intensity merge file list, which has 10 subjects, S1 underscore AV.fsg. Now, if you see .fsg, you know it's an average file. So that would be the average of the first subject's average file. Similarly, up to 10. On the channels labels, you can find channels, the number of channels in each set. So if there is any discrepancy, if there is any changes, then there are certain steps which can be used. In this case, we don't have that issue. But if there are certain discrepancies among this, and you want to ensure that all of them are evaluated in the same level, then there are certain steps which can be done. But as of now, you can just see this and then use the same values to continue. So all have the similar parameters here. Electrodes are same, sampling rate is same. Let us load. Let us go to the conditions tab now. So now this label on the top 60 decibel here, that is going to take all the 60 decibel triggers and average it. Similarly, the 70 decibel here, label here, is going to take all the 70 decibel, excuse me, all the 70 decibel triggers and average it. So that continues with all these files. In addition to all these files, I'm going to add one more condition, that is the difference between high and low. What happens when you give high intensity, which was defined already, and we want to know what is the difference between that and a low intensity. In order for that, I'm going to add a new one, new target condition. If you look at here, you might see, yes, new target. I'm going to label it as difference. This might slightly vary from the tutorial, but it is worth it. Yeah. So we have another column, difference here, where I want to, find the difference between the high and the low. So I need to check the column which comes as high. So here is that column. And in this column, I want to average all the high. So I will make a +1. Please attend carefully here, because I got confused when I started with this first. And later it took me some time to understand what it is. So yes. And the column above this is the low condition, which if I put +1, it is going to average and add both of these, low and high. Instead of that, I want the difference between the average of high and the average of low. I want the difference between them. So I just click upon it once again and I get -1, which means the difference will now find the difference between averages of high and averages of low. And beneath, over the bottom, you have two another sections which covers weighted average. So this section, if you want to use it, this will divide the result of the average by the number of trials of each condition. When you do that, you get the weighted average. But for now, we don't need this. Similarly, we have another divide result by sum plus. When you deselect that, what you're going to get is the sum of the averages, not the average of the averages. So let me continue with this. Let's go to the channel list. So here, by default, the second checkbox at the bottom would be active. So if it is not active, if it is not activated, you can still group and average certain channels. But with this, we don't want that. So we can just keep it clicked, so that we can't enter anything in these columns. Next is run script. So here, as I said earlier, if one or two electrodes, I don't know, I mean, if there are a certain number of electrodes which are damaged due to some reason, and you want to still compare by just maintaining the same standard across all of the studies, then you can interpolate, use this to interpolate to standard 81. This will interpolate the spatial interpolation for all the channels and make that all data set has 81 channel set data set, so that all are equal. It will interpolate spatially. Similarly, you can also interpolate temporarily. If the sampling rate was different, then you can use this option here. And you can also clip intervals by just providing the relevant information over this charts here. On the right side, you can still use the peak or else mean amplitude on each data set and average it. That is also possible. But for simplicity, we will continue directly with this. And all we need to do is just press OK. So now it is going to average the multiple averages. For each file. If you use this feature in your research, it is going to really save you a lot of time. Yes, it has come up with a name. So let us save. Yes, all subject underscore CC hyphen test and save it. So this is the average of this file, which still contains the difference also. Let me just increase the sensitivity of it. So as you can see, as we grow, as we continue with this, let us choose any one. And a topographic view, let us go to the topographic view of the low signal. I'm going to enlarge this. And here we will see the low. So here we have the low condition and we have this high condition. Please note the difference. And then you also can have them both simultaneously. You can see the purple one of the high condition where the frontal regions are more active. As you increase the intensity to high, you can see that frontal regions have certain signals which are generated. Similarly, for the difference, you can see the difference between the high and low. If you want to check with the low and high, this is the difference. And we have already computed the difference between the high and the low. Oh, I don't want to tell more about this because we have some things coming up in the next coming days, which will clear. But please do remember, there is a frontal activity also as we increase. Yeah, I spoiled it, Harald. Sorry.
Quite okay.
Okay.
Maybe one more thing is if you change the one charge to the original average reference, because in this file, actually, you can see that CZ is the reference electrode, but it actually has quite a lot of activity on it. So it's kind of, it's just also interesting to see the difference between the original recording and the original average reference in this particular example.
If you see this original recording, it is flat. Sorry, I just missed it. And I mean, as we know, it is all reference to CZ. However, when we change the montage to original average reference, we get the activity there, which means that CZ was active and it could have been missed if we did not use the new montages, different montages.
Yeah, but you can still see that the difference even with the original montage. It's just just interesting to remember that the montages are always kind of don't always show you the full picture. Yeah.
Yes. So always good to change the montage or else and then remontage and then play with it. Yeah. So I think I have covered.
There's one more question in the chat, so I'm trying to answer that briefly. It's about reading triggers from an PDF format, and originally the triggers are named R1, R2, etc. But in BESA they're shown as 1024. I think you can switch display of the triggers if you go to the options menu entry, and then under display you would find the option show internal trigger names instead of codes. This way you should get back to your original naming, I hope.